So welcome all. Today we are saying something about two-phase commit protocol. For understanding this two-phase commit protocol, in the last video we have seen something about the distributed transactions, where we have seen the transactions can be flat transaction or nested transaction, where actually in distributed transaction what we have learned is there will be a client which will initiate a transaction. So what will happen, you will have certain coordinator. Okay, what your client will do, it will just initiate some transaction. There will be some coordinator program. This coordinator program will help you in coordinating, right? Your client will initiate, there will be a coordinator, there are different servers. So what happens in distributed transaction, this transaction has some operations to be performed on the data objects which are at different servers. So there will be a coordinator. This coordinator will help you in coordinating the data access and operations being performed. Okay, so as we have seen in the last video, the coordinator will start with open transaction command, and after that this will end, or the transaction will end with close transaction command, right? Today we are going to see something about two-phase commit protocol. Yesterday or in the last video we would have seen something about one-phase commit protocol, where we saw that what will happen, coordinator will just send the canCommit message whether we can commit or not. It will send yes, we can commit, then done, right? Sorry, it will send some message that yes, commit it, commit the whatever you have changes, commit what you have changes, commit what you have changes. So what will happen, it will actually send that yes, we have committed, yes, we have committed, right? This was one phase commit. Today we are going to see something about two-phase commit protocol, where actually what will happen, in the first phase there is a coordinator and there are other servers where the task is being performed. So in the first phase what will happen, the coordinator will ask the participant whether they can commit or not. So then what will happen, these will reply that yes, they can commit, or no, they cannot commit. Okay, so then if this coordinator has received yes from all of them, then it will say that okay, since all of these are ready to, all of the participants are ready to commit, now we can commit the transaction. Just because you understand atomicity, atomicity says that either all of the operations of the transaction should be committed or none of them. So if the coordinator receives a message from all the participants that all of them can commit, then it will issue a commit transaction command, and then all of the participants will commit it, right? So that will be the second phase, where the coordinator will tell the participants to either commit or abort the transaction. If any one of them says that I cannot commit, this participant wants to abort, in that case all of them will have to abort. So this is how the two-phase atomic commit protocol will work. So basically here you will have certain set of operations, or if you want to see the image, you can see what happens in a start. The coordinator will say prepare for commit. It will ask the participants, all the participants, can you commit or not. Okay, and it will prepare to commit yes. Now whatever operations have been done, so operations are complete, then it will say yes, ready, right? So if this has received this yes message from all. Till the time it will keep waiting, and then after that it will issue a commit request to yes, do commit. Then all other participants will commit their work, commit their operations, will reflect the changes in the database and issue a message, have committed. Okay, so let me show these commands, that these are the commands where the first command is canCommit, where canCommit will be issued by the coordinator to participants. It will ask whether they are ready to commit or not, and participant will reply in yes or no. Okay, do commit is another command which will be issued by a coordinator to the participant to tell these participants that now you should commit your part of transaction. Do abort is another function which can be issued by command, which will be issued by the coordinator to participant to tell that there was some problem and now you should abort the part of transaction you have completed. Have committed is a message which will be sent by the participant to the coordinator that we have already committed the transaction. Means definitely they will commit after receiving the do commit message. Get decision is a message which will be sent by the participant to the coordinator in case what happens sometimes the coordinator has asked can commit or not, and what happened, the participant voted yes, it is ready to commit, but after some time, it has waited for some time, and till this time it has not received any message. Means what the procedure is the participant should receive a message, either do commit or do abort, but it has not received any message, it has waited for some time. So now it wants to find what is the status. Okay, so it is asking get decision. Get decision means okay, I have already voted yes or no, means yes, so I am waiting for committing, right? So since I am waiting to commit, I need some decision, what you have decided. So it asks the coordinator to share the decision. Okay, so server crash or delayed message, some kind of thing, these are the possibilities. So these are certain commands which will be used in the two-phase commit protocol. If you want to see the phases, these are the two phases. First phase will be voting phase, and second phase will be the completion according to outcome of vote. Okay, so in the first phase what happened, the coordinator sends this can commit message, okay, to the participant, and when a participant receives this message, what happens, it replies with yes or no vote. Okay, if it is ready, it can commit the part of its transaction, then it voted yes, and with this voting, what it does, it saves all the objects in permanent storage. Why does this participant saves this part of transaction in permanent storage? Because from the time it has voted for yes, it is ready to commit, until it commits, in between if the system crashes, then there will be a problem for the atomicity commit protocol, right? So what it does, as soon as it sends yes message, it saves this part of transaction in permanent storage, and with this, when do commit command is issued, it will reflect these changes in the database. Other thing is phase 2. In phase 2, what will happen? Coordinator will collect the vote, right? Some of them will say yes or no. If all of them will say yes, it is okay. So if there are no failures and all the votes are yes, in that case, coordinator decides to commit. and issued a do commit request. If there is some problem, if it has not received yes from all of them, then the coordinator decides to abort the transaction and sends a do abort request to all the participants that have voted yes. Now, participants that voted yes are waiting for a do commit or do abort request. We understand, so when a participant receives one of these messages, it acts accordingly, and in case of commit, it makes a have committed call as confirmation to the coordinator. Okay, so no problem. Now we can understand that these are the steps which are happening in two-phase commit protocol. However, one thing we can also understand is about in certain cases what will happen, there will be some time where some of these will be waiting. Okay, some either coordinator or participant will be waiting. When it will be waiting? It will be waiting when it says that we are ready to commit, sends a yes message, and between this time it doesn't know what will happen, whether it will say do commit or it will say do abort. So it is in uncertain state. So when this participant is in uncertain state, it is just waiting, right? So if there is a communication failure, something happened in between, and even after voting yes, it has not received any message whether we have to do commit or not, what will it do? Will it keep waiting for a lifetime? No, we should have some timeout options. So it will wait for a particular time, and after that it will abort the transaction. Similarly, in this case also, it is waiting here for a yes message from all of them, right? But if something happens and it is not receiving yes message from all the participants, in that case what will happen? It will wait for a certain period of time, and after that it will issue a do abort message to all the participants who have voted yes. So if we try to understand here, this is a first message canCommit, and then it receives the yes message, and then it issues a do commit or do abort message to all the participants. So if there are n participant, usually if we try to measure the performance of this, we can say it is 3n messages are being transmitted. You can say have committed is also a message, but while performance evaluation we are just considering these 3 messages. Just as soon as it will receive a do commit message, it has to commit. There is no other option after that. Okay. So these are something about two-phase commit protocol. However, till now what we have seen is the transactions are working from a coordinator to other servers, right? So it is basically a flat transaction. Now let us see what happens if at all the transaction is a nested transaction, right? There also we will have something, I should say, two-phase commit protocol, right? So what will happen is in this two-phase commit protocol for nested transaction, one thing we should understand that there will be a top level transaction. The outermost transaction, let me say there is a transaction T which will issue sub transactions, suppose T1 and T2. We have seen this example earlier also. T1 will issue some sub transactions T11, T12 and T21 and T22, right? So we have seen this example where this was on a particular server and these two were on a particular server and the third was on a different server, right? So then what happens, this kind of transaction will be a nested transaction. So this T will be top level transaction, right? And these for T1 and T2 are sub transaction. For T1 will have two sub transactions, T11 and T12. T2 has two sub transactions, T2 and T21 and T22, right? Now here in this case, what will happen? There will be something with open sub transaction. You will open sub transaction and so on, it will work, right? Now here for this transaction you will have a coordinator. Again it will open a sub transaction, so for this sub transaction you will have a coordinator which will coordinate these two sub transactions. So for this sub transaction also you will have a coordinator. Maybe it is not nesting, it is a different thing, but still you will have. So now in this case you will have to understand how this two-phase commit will work. So before understanding those two things, let us see two commands. One is open sub transaction. You can already understand. It will open a sub transaction and issue a sub transaction identifier. And get a status is another this thing where you will fit this transaction and find out its status, whether it is committed, aborted, or provisional. Provisional commit will be a status. Provisional commit will be a status where it says in the provisional commit that it is ready to commit. It is ready to commit, however it has not saved in permanent status, permanent storage. We remember that there is a status. What happens when the coordinator sends a message to a participant? Earlier in the flat case we have seen in the to the participant, coordinator is sending a message to the participant canCommit, then it issues a yes. If it is saying that yes, we are ready to commit, in that case it is saving all its information in a permanent storage. But still this provisional means that it is ready to commit. All the operations that has to be done it has performed, but it has not saved it in permanent storage. So these are the three status that it can return. Suppose there is an example, we have seen this, and here X says that X status is provisional commit. It is ready to commit, however it has not saved anything. T2 says it is going to abort. However, you can see here T12 was saying provisional commit, T21, T22 were also saying provisional commit, then that they are ready to commit, right? T11 is however aborting. Now in this case what we have to understand here is in this nested transaction, that if this parent T2 is aborting, in that case the child, or I should say the sub transactions T21 and T22 will have to abort. Okay. However, in this case, as T11 is aborting, still T11 can commit. Yeah, definitely. If at all this part of sub transaction is not committed, how will it commit? But still it can wait for reinitiating and commit it. So this T1 can issue a commit transaction. However, if it has aborted, in that case these T11 and T22 will have to abort. Now for these things, these transactions, or I should say the coordinators of these transactions, can maintain some information, like the main transaction T. It can maintain the information like these transactions, sub transactions are there, T1 and T2. The participants, okay, they will act as participant, and from these who are ready with provisional commit. So T11, T12, they are ready with provisional commit. However, T11 and T2 are talking about aborting. Okay, so since T2 is aborting, so we are not talking about the children of T2. Similarly, for T1 also there are two children, and these T1 itself and T12 is in commit list. However, T11 is in abort list. For T2, two children are there, and T2 is in abort list. T11, what happens? It is aborted. So T11 is in aborted list. T12 and T21. So T12 is going to participate. It is participating. However, T21 is not. Why? Because it has aborted. And T21, this, and T12, this was on the same server kind of thing. T12 and T21. Okay. T22 is okay. It is also aborting because parent has aborted. Okay. So in this way, some information they will maintain. But still, two-phase commit is waiting, where once they are ready to commit, the main transaction will issue a canCommit message. Okay, then definitely they can reply accordingly, yes, they can commit or not, but they will issue a canCommit message. So if this transaction issues a canCommit message to its another coordinators of child sub transaction, in that case this sub transaction will issue the same message to their own sub transaction and to the particular level of depth, and accordingly they will decide whether they can commit or not, and they will reply to their parent yes or no. And accordingly, two-phase commit, we already know that since they cannot, one of it has been aborted, so it cannot commit, so the transaction will issue a do abort message kind of thing. So these are certain things which will be here in case of flat and nested transactions. And definitely timeouts we have already seen. These are certain things we had to know. canCommit for flat two-phase commit protocol, where call from coordinator to participant to ask whether it can commit or commit a transaction. Replies with yes or no. It was in the flat two-phase. In the nested, we have it will ask its sub transaction and sub transaction, and then it will return. These are certain things about two-phase commit protocols. In next video, we will try to understand concurrency, where there will be locking or time stamping. Some of the things we will try to lock our resources. Then we will understand how deadlock can occur. Okay, so the main thing is we are going to understand how distributed deadlocks can be identified. So let us see in the next video. Thank you.